Hey everyone, I am Elise, and today I will demo InterRep for you all. To briefly let you know what InterRep does, it basically makes it possible to bring reputation from centralized platforms like Twitter, GitHub, Reddit to on-chain DApps. This is achieved by utilizing the semaphore protocol as along with a centralized server to act as a bridge. So right now I am in the staging environment. You can go on here to play around with the app to have a feel of how it functions. So let's attempt to click on this Twitter. So this is the OAuth process. Right. Once your account is verified, it is going to prompt you to this step where you can start generating your identity. And it put you into this Twitter group, which is represented by a semaphore contract, right? And you just sign a message, you join a group, and you also can leave a group as well, okay? So InterRep offer this public API where you can query straight into these endpoints for information that you want to know, because it does offer that centralized server. I'm gonna just try this locally for you to see. Right. And then if you you can even like use this, right? And see what is returning here. So check this out. This is pretty cool that they provide this. And one more thing that I also find interesting about this InterRep app is that it provides you with a subgraph. So this is quite interesting of InterRep is that it is integrated with the Graph protocol. You can read more online about the Graph protocol. Basically, it allows for application to query information on chain by indexing this all of the information. So this playground is GraphQL Playground. If you are familiar with GraphQL Playground with this, this is the existing schema for you to query these entities. Click here and you can see that it's returning these default off-chain groups, depth like 20, and then this is the root, all right, which is the root of the merkle tree of the semaphore contract that represented this off-chain group. And then you also have this concept called on-chain groups, which is created by other DApps, like the new social media network. That is it for the staging. Now I want to walk you through the code and see how everything is functioning. Okay. So I am now running this backend of all of the contracts. The InterRep contract is hosted on my local host, and I deployed it as a contract address right here. Okay, so with that running, now I'm gonna go to the front end and quick DB reset. This is the reset of the MongoDB. That is provided with this app. So, okay, now the MongoDB is reset. I am now, to keep things simple, I set the Merkle tree level to be 3 for us to easy to follow. Start the front end. So remember that because I set the tree level, tree depth to be 3, you're going to expect to have 8 leaves, right? 2 to the power of 3 is 8 in this Merkle tree. So I will just demo to you this flow for GitHub. Other OAuth accounts flow work pretty much the same, and you'll probably be able to figure it out. So same thing, click on GitHub, right? Prompt you to this step, and this generate identity, right? And then this button right here is generating your identity commitment for the Merkle tree. And if you look at this use group hook, this is where the identity commitment is generated on line 101 and 102. Okay. So then if you look here, right, the moment that your OAuth account is verified, your GitHub OAuth account is verified, the app posted your OAuth account group to the MongoDB instance, which if I refresh this, I will be able to see the OAuth group that I was put into. The reputation was calculated as not sufficient because I don't have any followers on GitHub. And my status in this group, did I join the group? Not yet, right? So that's why the status is false. Then, if I go to this app, right, and I click join group, right. Go here, and I look at my status in this GitHub group. It is now true. Okay. Now, I will explain to you in detail here how the Merkle tree is set up in this MongoDB. Okay. So first thing I want you to look at is this tree 0. This is when I first started the app, I did the yarn DB reset, and it's also seed the database with these fake Merkle roots. Okay. So you can see that the tree zeros here has level 0, 1, 2. Okay, with 0 being the leaf of the 0 tree, and 2 being the root of the 0 tree. Okay, and the hash for each of this level was calculated by using the Poseidon hash function, which is the very common hash function optimized for running ZK proof. Okay, and you can learn more about it if you're interested. So this tree only has up to level 2, right? And this will make sense later, but basically, when the tree has 3 levels, the root is at level 3, and you don't need another sibling node to hash with the root. You just basically return the root right there, right? So this will make sense later for you. So in the code, right, you realize that it called this endpoint, which is handled by this controller called handle OAuth identity, handle OAuth identity commitment. You can see that the identity commitment is pulled in here, which you can understand why, because it is part of this path on the route, right? And then you can see that here, this is a calculate reputation. And this is where it created the OAuth account, right? And if you go down here, what I want you to pay attention to is this append leaf, right? This append leaf function. And when you look closely at this function, right, it tried to find this merkle tree 0, which is this right here. Okay, it pulled that out. Okay, and then what it's trying to do here is detecting the current index, right? Where to insert the current node in the leaf in the leaf level of the tree. And right now we are at the first node, so current index is 0, right? So then from there, you look at line 42. This is where it created the merkle tree node, right? And you can see that this is actually interacting with the MongoDB also, where it called create, which then created this leaf right here with the hash, this hash, right? And if you look, you can see that it matched the hash right here. Okay, I logged this out on the console for you to follow. So then, right now we are at level 0, right? It basically, the function is set up. If you look, we're at level 0, and our current index is an even index. So it is looking into this 0 tree at the same level, level 0. What do you have at level 0 of this tree 0? The hash is 0, right? So it attempts to set the sibling node as at the same hash as zeros at that level. Okay, 0, 3 at that level. So then what you have here is it's trying to find a parent node, which we don't have one because this tree is brand new. So we add the leaf and we build it up to the root. So then, of course, because we're new to the tree, so we come here, right, where we try to create the parent node, which is the hash of the current node and the sibling node, right, which is a hash of this right here with the sibling node at 0, right? And then we have the hash of this. And if you look in the database, right, you can see that hash, this is a hash of the parent that just got created, right? And when you look at this leaf node, right, the parent is pointing to this object ID right here, okay? And so we just go through this for loop, right? And we just keep hashing the node and the sibling nodes, and we eventually move up to the top of the tree. I log all of this out. So then what happened at the top of the tree? We have the root, right, which is this hash. And it is level 3. Remember, I told you earlier about the tree 0, where it's only went up to level 2. It's because that's the highest level that we need to look up for a tree with a depth of 3. So on this tree node, what you have here, level 3, right? This is the root. You don't need to hash this root with any other sibling. You return this root. This is your merkle tree right here. Okay. So then, after all of that is created, and if you look at the log here, you can see that a cron was ran. Okay. This cron to pick up the changes in the database, basically. So it was looking for the merkle roots, right? And you can see that there is a merkle roots, okay, right there. So here is the line of code, line 29, where the front end is interacting with the Solidity contract in the backend. So I'm going to pull up the backend for you to see. You see this? So this is the transaction that was recorded on chain. The transaction hash is here, right? It is from my Ethereum test account. And this is the contract, InterRep contract address. Like you can see that is matching up here. This is InterRep contract. Okay. So that's for the cron. Okay. So one thing to note is the DB also keep track of the batches of the merkle roots that were posted on chain, and it set the transaction hash, right? And this is where it is saved. This is for record keeping. Right? You can see that I only posted one transaction, right? One merkle tree. Okay, so this is the hash for that, and this is the transaction, right? This is the transaction hash right here. Okay. So I believe that covers how the leaf is added to the merkle tree. So I want you to quickly look at the contracts code. Right? In this InterRep groups.sol, this is the add off-chain function, like off-chain group function. This is an external function. So for an encoding into this one, and it created an off-chain group on-chain, okay, like we saw in the terminal earlier. So that's one use case for off-chain group. Another use case here for InterRep is the on-chain group, which you can imagine like the apps or like a new social network. They can always create a group, but the difference is that they need to add this group admin. So they basically need to whitelist the admin addresses, because for online, like on-chain the app, only the admin can add member and remove member from the group. Okay, and members, in order to prove their membership in a group, they need to submit a zero knowledge proof, and this is the verify proof function. You know that this is avoiding the double signaling and all that. So I think this is the wrap up of my demo for InterRep. If you still have any questions for me, please do not hesitate to reach out to me on Discord and we can chat further. Thank you so much for listening.